Union types in TypeScript are a tool that gives you incredible strong type safety for complex typing scenarios. So let's take a look at an example in this video. When you first hear about type unions in TypeScript, it's often in the context of line 2 here. This is a query options type that we might use to set up a database request. And as you can see, we have a number of tables that we can query. Now, the non-union way to do this might be to just say string and assume that we're going to check in our actual application code that the table name given is an acceptable table. But we can do this at the type layer as well by using a union. So we can say we only allow querying of the users, widgets, and sessions table. The problem with this union is that it's really only restricting our table name. It's not contributing anything else to this query options type, but it can. Notice these options we have on lines 3 through 5. Because we don't know which table name will be passed in, we have to make all 3 of these IDs optional. We likely won't have a widget ID, for example, when we're querying the users table. And so again, we'll have to check in our application code to see if this is the users table, do we have a user ID, and so on. And then at the bottom here, we have limit and offset, which are both things that maybe all of these queries will need, and we'll come back to those in a bit. But first, it would be really great if we could use unions to strongly type the table name and the ID field together in some way. Well, we can, and let's create a new query options type here. This query options type is going to be a union, but not at the individual property level, but instead at the overall type level. So first, let's just say that the table is equal to users, and this has a user ID field that is a string. And then we can union that together using the pipe character, just like we did up here on line 2, and create another entire type. And so for example, this one can be for the widgets table, and instead of a user ID, we'll have a widget ID. And we can do the same thing for the sessions table. So now we have this type that is a union of 3 different types. And we could put these 3 individual types into their own type variable if you want, but we can also just union them together as literal types here. And now we can ensure that the right table name is always passed with the right ID. So for example, if we create options object here, we can say table equals users, and we can say widget ID equals 123. And if we do this, notice we have an error with widget ID. And this is that table users widget ID string is not assignable to query options. It knows that we can't use the widget ID field with the users table. So if we change this to user ID, then this should work just fine. Now, if we go back to widget ID, notice that if we use our old query options, there's no problem with this. It works just fine because there's nothing that binds the user table to the user ID field. That is one of the things that we get with the union at the outer type level, if you will, instead of the field level. But there are actually other big benefits that we can get from this type of union. Let's create our query function here. And just for the sake of this example, let's say we're going to return a string here, and we're just going to use the ID fields as the strings that we're going to return. The thing we can use here is a switch statement, and we want to switch on options.table. Now, if we hover over options.table here, notice the type of the table property. It's a union of the strings users, widgets, and sessions, which is essentially the same thing we had in our first example here. What's happening is TypeScript notices that all of the variants inside of query options have a table, and it knows what the values of those table properties are. And so it knows all of the possible values that options.table can be, and it can just show that as another type union. So now we know exactly what cases we need. We can have a case for the users table. And if I say I'm going to return options dot, notice as soon as I hit the dot, what our autocomplete shows us. We have table and we have user ID. And notice it knows the table specifically is users and not widgets or sessions. So we've essentially narrowed the type here. By using options.table and then a case for one of the values of table, we've narrowed the possibilities of what options can be. And now we know that options will have a user ID field. So we can grab that user ID field and return it. Now to satisfy our function here, I'm just going to throw a return of empty string at the bottom, but there's more cases that we can add, right? So we can add a case here for our widgets table. And if we return this, we can see that we know we have a widget ID. To be complete, we can return our session ID as well when we know we're in the session table. Now notice something else that TypeScript sees. It knows that down here we have some unreachable code. How does it know that? Well, it knows there are only 3 options for table, and we are handling all 3 of those options. And so we'll always return from one of these pieces of the switch statement. So we can remove our return at the end, and this is still valid code. So using a rich union type like this with a switch statement makes it really easy for us to be very type safe about objects that have various shapes that we need to support. But we can actually take this a step further. Let's say that we want to add something new to query options. Maybe we have a new table here. So I'll add another union here, and this will be table, let's say sales. We're gonna take a sale ID as a string. Notice that we get an error in our function here. The function lacks an ending return statement. So TypeScript immediately recognizes that this function doesn't return a string in all cases now, because there is a case that we're not handling here. So that's actually pretty great, because it means that we have this error now that tells us that our union has extended and we need to update this query function. This is actually, though, a side effect of the way that we're returning from within our case statements here. Let's say we had something different where maybe we have an ID here that defaults to an empty string, and then instead of returning inside of these, we actually just assign this ID, and then we'll return ID at the end. In this pattern, where we're not returning directly out of the switch statement, and frankly, this is probably the more common pattern, we don't have an error anymore because we're always returning a string. So how can we know that we aren't missing anything in our switch statement? How can we make it an exhaustive switch? Well, that's the name of the pattern I'm going to show you here next, an exhaustive switch. What we can do is add a default. Now, before I add this default, I'm going to remove sales here, and we'll see how this works. If we add a default here, what is the value of options in this default block? Pause the video and think about this for a sec if you want to. Well, the value of options is of type never. What it means is all of the case statements above the default block have exhausted all of the possibilities for the value of options.table. And that means if we reach this default block, there's nothing left that options can be. Never is a special TypeScript type, which means no value. It's impossible for us to get here, essentially. And so what we can do now is say that we expect never in this block. Let's create a utility for this. So we can say assert cannot reach. And we're gonna take some variable, it doesn't matter what, but it's gonna be of type never. And in here, we'll throw a new error. So assert cannot reach will throw an error if we ever call it at runtime, but at compile time, it expects to receive an argument of never. And that's exactly what options is here. So in here, we can call assert cannot reach, and we can pass it options. All right. Now, at this point, nothing breaks in our code here, right? Because what's happening is options.table is one of 3 values. We're handling those 3 values, and then we pass options, which is now a never value, to a function that takes a never value. And so this is perfectly valid TypeScript. But now let's add back our sales table here. So now if we scroll down here, now we have an error in the switch statement, even in the case where the switch statement isn't returning things. If we hover over the error, we can see that the argument of type table sales ID string is not assignable to never. So now what's happening is TypeScript recognizes there's a 4th value for our options.table, and that is of course our string sales. And it also recognizes that our switch statement here doesn't handle this case, and so when we get to the default block, the only value for options must be table is sales, and we can't pass that to our assert cannot reach. And so now we have a compile time error that tells us, hey, you're not handling a situation that can arise in your code. So let's add that. We can now add a case here for sales, and now TypeScript is happy once again. It recognizes that at this point options cannot be anything at all, so options is never, and our assert statement is now true once again. So this is the exhaustive switch pattern. I love that TypeScript gives us a way to type objects that may have many different shapes, pull those types together into a union like this, and then we can use something like an exhaustive switch to ensure that we're handling all of the possible states of our system. Now there's one thing that we didn't bring over from our old query options, and that is the limit and offset. And essentially we want to add these to every single possible value here. And so what we can do instead of a union is an intersection. So I can say right at the top here, paste that here. And instead of using the pipe character to union these, I'm going to use the ampersand to intersect them. Now this is not exactly right. If I hover over query options here, you can see that we have only intersected with the user table. So I'm going to need to put parentheses around the rest of this. And that way we are actually adding this to all of them. And so now you can see in limit and offset intersects with all of these things. And we can do a quick test here. For example, we can see that options dot now includes limit and offset. And if we add that maybe down here, we can see options dot includes limit and offset as well. So that way we can actually use the intersection. Intersection is another pretty powerful way of combining types. Maybe we'll do a separate video on that sometime, but just wanted to throw that in as a little bonus thing for you. So this has been how to use union types to do exhaustive switch statements in TypeScript, a really powerful way to make sure you're strongly typing complex types. If you enjoyed this video, please do like it, subscribe if you want to see more of this type of thing, and thanks for watching.